Topic Notes 9.2 Upwellings, Monsoons, and Tropical Cyclones. So anyone in Florida during the fall of 2017 probably recognizes this radar image. It's Hurricane Irma as it was coming across the southwest portion of Florida. However, due to the wobbling tracks, everyone from the Florida Keys, the East Coast, and the West Coast were under various evacuation notices, so it was pretty much a chaotic time. In this set of notes, we're going to be talking about how the interaction between the atmosphere and the ocean can create some of these extreme phenomenons. So checking out our main ideas, first off, we're going to talk about upwelling and how that causes nutrient-rich water to reach the surface and increase marine productivity. Then we're going to look at the fluctuations in global wind and precipitation patterns that can cause periodic and annual events such as El Nino and monsoons. And finally, we'll talk about how tropical cyclones are formed by intense low-pressure systems and can cause major damage. Once again, make sure you check out those learning goals. They are also replicated on your scales. So the first thing we're going to look at is upwelling, and this is going to be a theme throughout what we talk about all year. And it is specifically tied to productivity. Upwelling is the movement of cold, nutrient-rich water from the seabed vertically to the ocean surface. One of the classic ways upwelling occurs has to do with offshore wind. With that steady offshore wind, you create a low-pressure zone along the continental margin, bringing up colder water from the deeper areas. Another way this can happen is through the deflection of deep ocean currents through mid-ocean ridges and seamounts that sort of deflect the currents upwards. This map shows you all of the high productivity areas around the world, and they coincide with areas of upwelling. Due to the fact that plankton and pretty much anything else alive, as they die or shed fecal matter, it basically drops to the bottom and becomes part of the deep sea. And at that point, those nutrients get trapped down there. So anytime we have upwelling, it's acting like fertilizer to surface waters, increasing that productivity. And of course, with the higher productivity, you have a more diverse and healthy ecosystem. Now, of course, remember that too much of a good thing is, of course, not a good thing, especially when you have coastal regions with lots of nutrient load being dumped into the water. This can cause eutrophication, and that can actually lead to negative environmental effects as well. Now, this concept of upwelling is really important when we're talking about El Nino or the Southern Oscillation. Now, El Nino is referred to the situation where a warm current develops off the coast of Ecuador, usually around December, which can cause a widespread death in the local food chains. Now, as you might know, the western coast of South America, from Ecuador, Peru, they all rely a lot on the healthy fisheries for their economic development and growth. So when El Nino events occur, it can have a very negative and damaging impact. So to understand how this works, we first need to look at the normal conditions in the Pacific. Generally, there are strong southwesterly winds that blow water away from the coast of South America. This allows for upwelling, cold nutrient water that moves towards the surface along the coastline. This is what causes such a high productivity in the area and, of course, supports such a diverse fishery. Now, also under these normal conditions, we have westerly winds that push a large amount of the warm water towards Australia and Asia. Now, as warm water evaporates, it provides a lot of needed rain to Australia and Asia, while on the other hand, keeping the eastern Pacific relatively dry. Now, periodically, about every 3 to 5 years, sometimes up to 7, weather patterns in the Pacific change. Essentially, it's the trade winds that change, effectively shutting down the upwelling along the Pacific coast of South America. This change in wind patterns also stops the moisture from making it all the way over to Australia and Indonesia, putting them into extreme drought conditions. On the flip side, Peru and the Eastern Pacific get a lot more rain. And of course, another really big problem with this is that the productivity along the Pacific South American coastline also shuts down, which means you have a crash of your fisheries. And this has not only an environmental impact, but it also has an economic impact to the people that live in South America. Now, we're still learning about El Nino and what are the triggers that actually cause this shift to occur. Either way, it really does affect almost the entire Pacific Ocean basin, and it even has some ramifications in the Atlantic in terms of heat and energy transfers through the atmosphere. So, an El Nino is identified by 3 consecutive months where equatorial Pacific sea surface temperatures are at or over a half a degree Celsius above normal. There are 3 of the more recent large events that we've recorded. The first is in 1982 to 83, where temperatures rose about 2.1 degrees Celsius. This ended up causing flooding in the eastern Pacific basin and obviously the crashing of some of the fisheries. Beating that was the 1997-98 El Nino, where temperatures rose about 2.3 degrees Celsius. This, at the time, was the strongest event ever recorded. However, the 2015 and 16 event had temperatures rise about 2.3 degrees Celsius above normal, and that may be the strongest yet. We are still waiting for final evaluations on it. Now, El Nino is not the only actual fluctuation that we have. A much more predictable and annual fluctuation are the monsoons in the Indian Ocean. Monsoons are seasonal winds in India that blow from the southwest during the summer and the northeast during the winter. This is created by the uneven heat capacity of the land and the sea. During the summer months, the land becomes much warmer. This sets up a scenario where you have high pressure over the ocean with cooler water and low pressure and warmer water on land. Air is always going to, of course, move from high to low pressure, creating those onshore winds. That's going to bring ocean moisture to the land, and as they hit the mountains, they're going to rise, and it's going to dump all that precipitation, causing massive amounts of rain and, of course, flooding. So in the winter, the ocean holds more heat than the land. This causes a reversal, where you have the cool, dry air from the land blowing towards the ocean. In this scenario, the Asian landmass is left with a drought conditions that really pretty much exceeds through the summer until the monsoons return. As you can imagine, having both floods and droughts annually can cause problems with human populations, and they do struggle with balancing all of this. Okay, our next and final topic has to do with tropical cyclones, otherwise known as hurricanes or typhoons. Essentially, all 3 of these names mean the same thing. Tropical cyclones, hurricanes, and typhoons. It really just depends on what part of the ocean you're in. They are essentially localized, intense, low-pressure wind systems that form over tropical oceans with, of course, strong winds. Now, we can rank these storms based on their sustained winds or their maximum sustained winds, with usually when you think about 175, 180 mile an hour winds, those are very strong Category 5 storms. But if you look at the table on the right there, you'll also notice the pressure listed for some of these storms. And the lower the pressure, the stronger that low pressure system is. Generally, it means the stronger the winds, but more damaging the storm. You can see down there where Hurricane Irma ranks in 2017 with the sustained winds of 175 miles per hour with a 929 millibars of pressure at the center. Now, for hurricanes or tropical cyclones to form, they need warm water, and that's one of the reasons why hurricane season tends to be in the summer months as you go into the fall. Now, this map shows you areas of hurricane development globally. You can also see the differentiation between the different types of names. usually off of the Americas, we call them hurricanes. In the Indian Ocean, they're cyclones. And in the Pacific, usually, especially the Western Pacific, you look at the term typhoons. Either way, there is a predictability to the formation and the paths annually of these storms. For the Atlantic, as an example, that we're very familiar with, these storms tend to form in the equatorial regions off of Africa, and they move towards the Caribbean with paths that can lead them up the eastern seaboard of the US into the Gulf of Mexico or sort of into Mexico. Now, the actual path of these storms is dictated by, of course, a lot of factors. A lot of it has to do with the central high pressure that's over the Atlantic and how far that nudges in towards the eastern seaboard. It also has a lot to do with the jet stream and how far it's dipping down and what steering currents are actually involved. Now, these conditions that dictate the movement of these hurricanes can change from the early part of the hurricane season towards the latter part of the hurricane season. It's one of the reasons why we don't tend to get a lot of the hurricanes that affect us until we get into the late August into September and October range. However, we have also had late spring hurricanes pop up as well. Nature is full of surprises, but it really is that key of warm water that has to fuel these storms. So, as the air over that warm water rises due to its low density, it's being loaded with water vapor through evaporation. That rising air creates a low pressure area that eventually will form the eye of the storm. As the storm starts to develop and strengthen, it will start to pull in cooler air. That air will then warm and rise and eventually create those winds. As water vapor condenses as it rises and cools, it's going to release large amounts of stored energy, that latent heat. This, of course, increases that heat energy, causing more evaporation and stronger winds. In a healthy storm, you're going to have that outflow and inflow coming into the storm, rising warm air, high condensation, and lots of energy being released. Now, the system itself begins to spin because of the Earth's rotation, specifically the Coriolis effect that we talked about when we talked about atmospheric winds and circulation. Now, the prevailing winds in a particular area in a particular time of year are going to help steer these storms in different directions. Now, these storms have a huge amount of impact. On humans, obviously, the high winds destroy a lot of property, especially along the coastlines where there's not a lot of protection. By far, however, the factor that generally causes the most loss in life has to do with flooding, especially in low-lying areas, and obviously it puts people in danger, especially if they haven't evacuated. And then, of course, the damage to property is pretty severe during those floodings as well. And of course, very much related to flooding is the wave and storm surge that can accompany these storms. Not only can it provide flooding in coastal regions, but it can also erode shorelines and create a lot of damage. This is why it's so important to have a plan far before hurricane season comes along, so you know what to do. As soon as a hurricane watch is put up and it moves from a watch to a warning, and various areas, including your own, may be evacuated, you are ready for each of those moves in a timely manner to make sure you're in a safe position to either ride out the storm or move to a better area. Now, from an environmental standpoint, hurricanes have a pretty big impact as well. If you go down to the Keys right after some of these massive storms, specifically Irma here recently, you can find a lot of damaged coral. Now, when we look at ecosystems being damaged by a hurricane, it's not always a bad thing. Sometimes these damages, whether it's to a dune system, forests, coral reefs, it actually provides opportunity for new growth to occur and kind of a new reinvention of the area. And that can actually be a good thing. Of course, it's sad to see some of the various casualties or problems with some of the wildlife. There's a picture down on the bottom on the right there of a manatee that literally got dry docked during a storm that had to be rescued. There's also some unintended issues with human development. When we have these storms, sometimes they have a tendency to blow a lot of or wash a lot of the nutrients that we've kind of loaded into our terrestrial and freshwater habitats out into the ocean, and that can cause a eutrophic sort of situation for the coastal communities. All right, it's time to throw it back to you. So here's your in-depth question for today. How can increased ocean temperatures impact tropical cyclone development and strength? I'll leave it up to you to think about. And of course, until next time, keep thinking.